Hi, it's Thursday, June 18th, 2020. My name is Noah Seeley, and welcome to my channel. So today I thought we would finish up our discussion on the paper called Prioritized Experience Replay by the Google DeepMind's team. Yesterday we covered the meat and potatoes of the paper, so if you haven't yet watched part 1 of this discussion, I'll link it in the description below for you guys to go check out before watching this one. Apart from missing part 1, if anything related to reinforcement learning still seems a little bit fuzzy, I invite you to go check out my 2-part intro to reinforcement learning that I'll link in the description below along with part 1. They're quick videos and cover the definitions, processes, and applications used in reinforcement learning. Today we'll be finishing up this paper, so we'll be going over the experiments, discussion, extensions, and conclusion sections. So just as a quick recap of part 1, recall that the agent the Google DeepMind's team came up with was a variant of a double DQN agent that instead of using uniform sampled experience replay, used their new algorithm called the Prioritized Experience Replay. The Prioritized Experience Replay uses stochastic prioritization as well as importance samplings methods, 2 methods which we discussed further yesterday. So if all that makes sense, let's finish off this paper.
The experiment section starts off by stating that performance is tested under a collection of Atari game benchmarks. They say that this is appropriate as the games offer a variety of challenges appropriate for rating the performance of an agent. They hypothesize learning will be more efficient while using their prioritized experience replay algorithm. Basically, they're going to compare 2 identical double DQN agents, which are very similar to the agents discussed in the Playing Atari with Deep Reinforcement Learning paper by the DeepMind's technology teams. The only difference is that one will uniformly sample iterations from their replay memory, while the other agent will sample according to the prioritized experience replay algorithm, which this paper discusses. So basically, they're trying to isolate only the experience replay algorithms in order to compare their performance and then validate if their implementation has any effect on learning. The team produced the results from running the agents through the games, and their main evaluation value was what they call the quality of the best policy in terms of average score per episode. So there are more results to be found in the tables that can be found in the appendices, but the table shown here summarizes all of those quite nicely. For the regular DQN agent, they found that the prioritized experience replay agent had significantly better results in 41 out of the 49 games played. Across these 49 games, the medium normalized performance went from 48% to 106%. As for the double DQN agent, similar results were found. The outperformance of the state-of-the-art double DQN model actually led the prioritized experience replay model to become a state-of-the-art model of its own, improving performance significantly on many games and even outperforming human experts in a few games for the first time ever. The figures shown here show that for each game, prioritized experience replay improved learning significantly, allowing agents to converge almost twice as fast. So yeah, the main takeaway from this section is that the agents implemented with a prioritized experience replay algorithm were able to learn games faster and outperform agents who didn't. Prioritized experience replay was able to contribute to a state-of-the-art agent which could perform very well on various Atari challenges. The discussion starts with the team talking about how they thought the rank-based variant of the prioritized experience replay algorithm would perform better than the directly proportional one. Its samples would be less affected by outliers and more diverse. With that being said, they say that it can also be blind to relative error scales, which would cause a performance drop if there is a situation where a reward could be exploited. They say that in the end, though, both variants actually performed pretty much the same. The researchers believe that it's because the DQN agent already compensates for outliers, which could contribute to the rank-based variant being less effective in this case. On another note, the team observed 2 problems with uniform sampling algorithms. The first is that many iterations are never actually played while in the sliding window, and some only played a long time after they're encountered. The second issue is that the uniform sampling is biased toward older iterations that may have been made by a policy which has been updated thousands of times since the iteration's creation. The prioritized experience replay algorithm fixes these issues as it has a bonus for unseen iterations, as well as takes on more recent iterations naturally as they typically have a higher error. The paper quotes that this is because older iterations have had more time to be corrected, as well as the fact that novel data tends to be less well predicted by the value function. The section ends with the team commenting on how neural networks and prioritized experience replay have a special relationship, as the neural network seems to tend to put more resources into learning iterations that have worse representations or are less learned by the agent. This will contribute to learning as iterations that have already been learned a lot by the agent will be put away, while those iterations that have not been so well learned will be brought back up again and again by the agent in order to learn them. The extensions section basically describes where more progress related to the prioritized experience replay could be made. They discuss future projects or implementations using ideas taken from this paper in order to improve on other areas of machine learning. I'm not going to delve super into any of these areas, but the team mentions prioritize supervised learning, off-policy replay, feedback for exploration, and prioritize memories. I think the amount of areas of machine learning that prioritization can fit into is really interesting, as it seems to speed up learning by making a model basically process through datasets or environments a lot faster, skipping over a lot of redundant iterations or data, and instead putting resources into the unknown, or in this case, the unlearned. If anyone wants more from these sections though, let me know in the comment section below, and I can make a quick video delving into the areas that this team suggests prioritization can work in. The conclusion section, as always, just wraps everything up that we've been talking about in these last two videos. They basically restate that prioritized experience replay makes an agent that uses a replay memory able to learn more efficiently. The team ends by saying that they were able to create a DQN agent with prioritized experience replay that could outperform the same agent that used a uniform sampling experience replay, and were even able to create a state-of-the-art agent for the Atari games benchmark. So that concludes the series of discussion on the prioritized experience replay paper by the Google DeepMind team. I hope you learned just as much as I did regarding these reinforcement learning topics. There are also some more technical bits in today's sections that I did not delve into, so as always, I've linked all resources in the description below for you guys to check out yourselves. If you feel that I've missed anything or got anything wrong, please let me know in the comment section below. That's all for today. Thanks for watching. See you tomorrow.